Login accepted.
Hello, everybody. I hope you can all hear me well enough. Welcome to this presentation on building database applications with Micronaut Data and GraalVM. My name is Graeme Rocher. I am an architect at Oracle Labs, where I lead the contributions from Oracle Labs to the Micronaut framework. I'm also the creator of a number of different open source frameworks that you may have heard of. One of them is called Grails. Another one is called Graeme, which is also database related. I enjoy challenging the status quo and innovating and doing different things and going against the grain and coming with new ideas. So if you want to chat to me afterwards, I'll be around at the conference, and you can connect with me on Twitter or GitHub or whichever social avenue you prefer. So I don't know how many of you have actually heard of Micronaut. There is actually a more in-depth Micronaut and GraalVM talk tomorrow, where I'll go through more introductory material. This talk is more focused on Micronaut Data in particular. But I do want to just give you a brief overview. So the Micronaut framework is a relatively new, I guess, not so new nowadays, but relatively new framework that's focused on modern architectures, such as serverless and microservices. However, it's not only for that. It's really an application programming model that's based on annotations, so that you can really write any kind of application. And you have, some people writing command line applications. You have some people writing even JavaFX applications or desktop applications with it. Anything that has a static void main, because basically it's an annotation-based programming model that allows things like dependency injection, aspect-oriented programming, and so on. So if you're used to the Spring way of doing things, Spring users often find they're very, very comfortable using Micronaut. It's very, very similar in a lot of ways. Where it's different is that it essentially computes your framework infrastructure during the compilation phase by hooking into Java-C, and eliminates the use of things like reflection, the runtime creation of proxies, and it essentially computes the dependency injection part at build time. We have a client and server based on the Netty IO toolkit, but they're not the only clients and servers that Micronaut supports. There's different kinds of clients and servers. We support gRPC, we support Tomcat, we support other, the servlet environment. It's really a flexible framework that you can adapt and use for whatever scenario you want. And it has major contributions from multiple different companies, Oracle being one of them. If you have not heard of GraalVM, and I'll go into a lot more detail about GraalVM tomorrow, as I said, do come to my talk. It's again, relatively new virtual machine out of Oracle Labs. It has a JIT component that is able to replace the regular JDK's JIT, so if you want to run it in JVM mode. And that's able to increase application throughput, reducing latency, in many cases between 20 and 30%. Possibly what it's more famous for more recently is GraalVM's ability using the native image tool to compile applications into self-contained native binaries, so native images for the kind of architecture you're running on. And that's really been popular in cloud deployments, for example, serverless, for example, low memory footprint memory microservices deployed to Kubernetes. But it has many different aspects. GraalVM has a truffle language framework and many other things. So in terms of Micronaut Data is a module that's built on top of Micronaut's programming model. And it's basically an implementation of the data access pattern, repository data access pattern, essentially. So the difference with Micronaut Data compared to other technologies that are similar is it does the computation at compilation time. So it computes the queries to execute during compilation instead of waiting to runtime to do the computation. This also means it has a lot of active type checking. So it will type check the usage of your repositories and fail if there is any incorrect usage of the repositories you define. And of course, it's automatically, because there's no reflection usage, it's automatically compatible with GraalVM native image. All of the implementation of Micronaut Data that we support work with native image out of the box. A little bit of a history. I mentioned the repository pattern, but maybe everybody doesn't aware of it. I'm sure a lot of you have been exposed to it at some point. But basically, I guess it started with active record in Ruby on Rails, where you could define your book class and, hey, find by title on the book in your Ruby on Rails application. And that got me really excited. The only problem was I was a JVM developer at the time. And I was like, damn, this is really cool, but I can't use this because I'm building like enterprise applications. They're running on Tomcat and so forth. So I was working at a company at a time, and I saw this language called Groovy, and I thought, wow, we could do the same thing. And I wrote something called GORM for Grails, which I think was the first technology really to bring active record to the JVM. And it basically was built on top of Hibernate, but you could do all of the repository patterns, all of the automatic computation. Later on, I joined SpringSource, which later became part of VMware, etc. And I worked on another project, which probably is the most famous implementation of the repository pattern, which is Spring Data. So I helped at the beginning of the creation of Spring Data define how it was going to work, because it was basically more or less based on how GORM works. When we started looking at Micronaut and seeing what could be improved or what could be done better with the repository pattern and generally data access patterns, we kind of, with both GORM and Spring Data, what happens is at runtime, the method call is intercepted of what query you're going to execute. So, for example, find by title or whatever. And then it's parsed using regex or regular expressions or whatever, and transformed into a SQL or JPA QL query or whatever at runtime. That means there's a little bit of overhead in terms of memory consumption. There's a lot of caching involved, so it's not huge, but there's overhead in intercepting, computing, caching, re-establishing what the query is, and then executing. So we thought, Micronaut has this amazing compile time plugin architecture, so let's do the same thing, but let's compute the queries whilst the application is compiling, so we can reduce the memory footprint required and essentially make the query layer more efficient, right? So that's the real difference between Micronaut Data. But in reality, Micronaut Data, the code for Micronaut Data that you find on GitHub today is essentially a fork of GORM. So if you want to go through the history of the code base, you'll find that we forked GORM from Grails and essentially reused large parts of the GORM code base. GORM had the significant disadvantage of being limited to the Groovy language, so that limited its adoption. Micronaut Data works with Java, it works with Kotlin, it works with Groovy. So whatever you're building, it will work for you. So I like doing demos. I don't know about you guys. I don't know if you like watching demos, but I like doing demos. So a lot of the rest of my talk will just be demos. Things may go wrong, but it could be fun, So we'll see. Just gonna quit that. Should have done it beforehand. Okay, so I've got a application here, And the first thing I want to point out is that Micronaut Data has multiple implementations, right? So the first implementation I'm going to show you is Micronaut Data JPA. So Micronaut Data JPA, as you can imagine, is built on JPA, and JPA just means hibernate nowadays, pretty much. So it's a Hibernate-based implementation, right? So I have an example application here, and it's a Micronaut application, right? And we have some entities. Now, one of the things I really recommend whenever you're building database applications, whether you're using Hibernate or not, whether you're using SQL or Hibernate, is to incorporate schema migration into the way you build applications. I see a lot of projects that they basically enable the thing in Hibernate. It's called HBM to DDL auto, and they generate the schema from the model, and then the schema gets generated from your Java classes, and then we're just like, ship it, right? This is like generally a bad idea. So in this example here, I stole some schema. Sorry, why am I not showing my ID either? That's weird. Okay, let's go back over here. Okay, I'm going to undo that. Okay. Okay. So let's see. Full screen. Why is it stuck on that slide? Okay, I'm going to undo this, and I'm going to put it back in, and we're going to see if that sorts out the problem. No? Sorry? Yes, that's probably what's going on here. Okay, fine. Newbie error on the mirroring of the screen issue. So display. All right, hopefully that's a whole bunch of it. Apologies for that. Okay, the first technical issue out the way. So, so what I have here is an example project here, and I have a schema, and I'm using Flyway, right, to basically set up the schema. It's got two tables. We're using the Star Wars data set here, where we've got people and planets, and a bunch of example data, and this gets set up when my application runs, okay? And then I have two JPA entity classes, right? So I have a person class, and I have, which is basically a typical Java bean, getter and setter arrangement. And I have a planet class, which maps to the respective tables in my database application, right? So with Micronaut Data, and if you're familiar with Spring Data, it's very similar. What you can essentially do is define interfaces. So I can define a person repository, like so, and it extends from CRUD repository, person, long. And these two arguments are basically the entity type and the ID type, right? CRUD repository is interesting. It's basically an interface, parent interface that you can optionally extend that provides all the operations for CRUD operations, right? So what will happen when Micronaut compiles this class, it'll actually compute all of the queries for all of the methods that are defined within it. The only thing you have to do is annotate it with that repository. And we can do the same with the planet repository. Define another one. There we go. And with that, we can start testing out the application. So basically, I'm using @Micronaut test, and what that does is it will automatically bootstrap the application and allow components to be dependency injected into it. So I can actually dependency inject into my JUnit 5 method here the person repository and the planet repository. There we go. I can dependency inject those two directly into my method. And now we can start using these to perform CRUD operations. So for example, we want to list all the planets. So we can call find all, which already exists, and get all the planets. And we can iterate over those and, for example, print out the names of all the planets. Whoops, that is a bad mistake. Why is that? Oh, yes, thank you. Today, the demo is going. Thank you, you guys are awake, that's for sure. That's very helpful. So yeah, we can print out all the names of all the planets, right? So if we run this, and you'll see that very simply we're querying all the data and we're getting all the planets that are part of my data set, etc., etc. This is calling the find all method, which returns an iterable, and it's inherited from the CRUD repository class. But, we can, of course, create new planets by calling things like save. We can delete existing ones by calling, or we can delete them all by calling delete all, or delete particular planets, or delete some of them. We can update and perform update operations directly, and those will be automatically implemented for us. Now, one of the things to be aware is that Micronaut test is actually providing me with a transaction around this test execution that actually rolls back every time a test completes. We can, of course, disable that if we wanted to, but we do not have to. Now, one of the things I want to demonstrate is optimizing queries. So, it's very common to, for example, see in the Hibernate world where we say, let's introduce a variable here where we get all the people, and then we iterate over the people, and maybe we output the person name. And we decide to output, OK, I'm going to output the planet they're from and the name of the planet, right? Let's run that, and we'll see that what you'll get is a lot of selects, right? So this is the typical n+1 select problem where you have the initial query to get the person for each person, but then you have a query per planet, because if we look at the model that we have here, the entity class has a person and it has an associated planet in a kind of many-to-one arrangement, right? So we get n+1 queries for each person, and then another query for each planet to lazily load the planet here. And with Micronaut Data and Micronaut Data JPA in particular, we want to obviously provide control over that. So we support both JPA's entity graph option, but also you can easily override methods from the parent class. So for example, I can override this parent class method here, which I'm calling over here, and I can say I want to join planet. Yeah, so when I execute this query, I just want to get all the planets. You can also change the return type. So I can say, I don't want to return an iterable. I want to use the ability in Java to alter the return type, covariant return types, to return a list instead. And Micronaut Data will respect that. So, if we run this again, basically, you'll see, and if we look at the query output that we did before, now we don't have all the n+1 select problems. We don't have all those selects. We have a single select to get all the people, and a join query to also retrieve the planet, right? So we have the ability in Micronaut Data to allow you to control joins, and you can specify entire paths. So if planet had a, I don't know, solar system, so you can basically put paths in there to create joins across and optimize your queries in an appropriate way. Another important thing I want to note about the schema that we have here is that in the schema that was defined, each table here has a created date and updated date timestamp. Yeah. Now, Micronaut Data has built-in ability to automatically populate those for you, as well as a general eventing system, so where you can declare on, for example, an instance that is the property that this is a date created and this is a date updated, and Micronaut Data will ensure that when you save a new instance, those values are automatically populated before the insert happens, and you don't have to manually populate those instance, and it will make sure that when you do an update, only the updated column is populated. So Micronaut Data has various features and additions to it that generally makes creating database applications an easier experience. Now, the other thing that we haven't seen here is, obviously, I'm just using the built-in methods of CRUD repository and the ones that I inherited. But you can also write whatever custom queries that you want. So, for example, if we look at the person repository here, we have various properties such as name, height, etc., etc. And this is where the repository pattern comes in that we can, on the person repository, we can write queries. We can say list person, find, and both IntelliJ and our latest VS Code extensions provide really great completion for this. So, for example, I can say, find the average height by name, and we get this completion. So I'm going to find the average height by name, and then we can write a query here. Let's see, we were going to say person repository, find average height by name, Skywalker, or something like that. And let's see what happens. Compilation error. OK, so this is interesting. So remember I mentioned to you about the active type checking that you get with Micronaut Data. So I've actually made a mistake in my query here, and it's telling me exactly that. It's saying, cannot implement the method repository, I cannot implement find average height by name, because the query results in a type number, whilst the method returns an incompatible type person, right? So I'm asking for the average height, and obviously the average height, they're going to come back here. Height is an integer. So I can't actually return a list of person. I made a mistake there in forgetting to change their return type. But the active compilation time type checking is ensuring that I'm not able to define a query that would otherwise fail at runtime. So this is a major difference between Micronaut Data versus Spring Data versus Graeme versus its predecessors. It's the active compilation time checking that you're doing the right thing. And the same thing happens if I'm like, for example, oops, now it's failing just because of, should be failing, right? So yeah, and it extends like to properties, So I'm saying find average height by name, by the name of the person. So, so in this case, I want to find the average height of the different members of the Skywalker family. But if I were to misspell like name, and actually in this case the IDE is clever enough to point it out as well that, that's not going to work. It's saying it cannot resolve property name, but even if I did try and run it, it'll say I cannot query entity person on non-existent property nam, right? So it'll actively fail compilation saying that it can't execute that query, right? It's not possible. Whilst in frameworks like Spring Data or others, you'll get a runtime error that you'll have to try to interpret as to exactly, what is the issue here. So, and you can chain these, can say, there's all sorts of queries you can do here to, this is, you can instead of, you can list all the people. My ID is being slow. And you can say, find all by, birth year after or birth year before, and all of this completes in a way that makes sense. You can say find all by name contains, contains sky, for example. If I wanted to pass in, I obviously can't do that. But there's a whole expression format of writing queries and they automatically get implemented for you. And another thing I want to point out is that I'm using interfaces here, but these can also be abstract classes. So this could be an abstract class that implements CRUD repository, and you can make all the methods abstract. And that means you can combine behavior, right? So you can, sorry, that should be public abstract. That means you can combine behavior. For example, if I had some custom logic in here, I could inject the entity manager, the JPA entity manager, into my person repository, and I could inject this here, and I could write my own custom method that lists people or whatever, and that maybe where I'm using some logic to find all the people, for example, like here, but then I'm using the entity manager as well to create some other query for each person. You can write whatever logic you want, and you can combine them with the logic that's implemented for you. So basically, Micronaut Data is taking like the heavy lifting for you, the hard work, and you just focus on the bits that you want to implement yourself, right? And you can make this method transactional if you want to. So there's really a lot of flexibility that you can get from Micronaut Data. So I'm going to just pop into terminal here because I'm running behind already in my presentation. And I want to get on to other things. I'm going to head over back to my slides. And I'm going to go on to the next slide. So let's see. OK. So now I'm going to do a demo of Micronaut Data JDBC. OK, so you've seen Micronaut Data JPA. I'm going to switch over, and I'm going to look at a completely different implementation. So like I said, Micronaut Data has multiple backends. JPA is one of them. Now I'm going to switch over to Micronaut Data JDBC. What is Micronaut Data JDBC? It's a pure JDBC implementation of Micronaut Data and the repository pattern. So we get all the same features. We get all the same features that you get on top of JPA, except you don't have it's just a simple data mapper that just uses JDBC under the covers. Now, the cool thing about this is that, this is more for people who love like SQL. If you really like SQL and you don't want an ORM tool to get in your way, you don't want an object relational mapper, you just want to focus on your SQL and you want to map it to result sets, right? That's all you want. You don't want lazy loading. You don't want proxies, you don't want a stateful session, then Micronaut Data JDBC is perfect because you just say, I have this SQL, and you can write your own custom SQL, you can do whatever you want, and I want to map it to this type. End of story, right? And one of the cool things about it is it supports records. So, okay, so okay, why is that not? Having trouble with the projectors again. Swap displays. Okay. Okay. Why? Okay. There we go. Don't think I'm going full screen anymore. I'm just going to avoid it. Okay, so it supports records. So as you can see here, instead of the Java being getters and setters and all the JPA and so forth, stuff like that, I can just define Java 17 and above records, right? So I've got a record here that models my person class, and look how much shorter it is. Records are really, really, really pretty. We love records. And you can define just a record here. We can even include, for example, things like the date created and the date updated record components. All the properties that are optional, you can annotate them with nullable. So Micronaut has like active checking of null. So if you want something to be null, you have to annotate it with nullable. And you can create these records. And to simplify your lives, you can create secondary record constructors, right? So if I want to persist, easily create a person with just the required properties, name and planet, and save it with everything else being null, I can easily do that, and I can create secondary constructors. And the same thing with the planet type. So we've turned it into a record. And Micronaut Data JDBC is much lighter weight. But more or less it works the same way. So I can create a interface planet repository, for example. Extends CRUD repository, and again, it can be planet and ID long, right? The only really difference is instead of repository, we annotate this with @JDBC repository, and we specify a dialect. In this case, I'm using an H2 in-memory database. And the same thing with the person repository, right? There we go, person. And there we have my two JDBC repositories, and now I don't have any object relational mapping tool involved. It's just pure JDBC calls going on in here. And I can define these as arguments just the same way. And I can define the person repository. Yeah. And I can query exactly the same way. So I can say, person repository, find all to get all the people, iterate over them. And this time, because I'm using records, we call the record person, the record component accessor, and we can easily do that. So if I run this, let's see what happens, and see if it actually works. Okay, so it doesn't actually work, and that's interesting. It fails, in fact, because I'm specifying a null argument to planet. And that's because a person argument, like I said, the planet argument is an association, so you can't actually construct a person without a planet. So, we have had debates about failing this at compilation time. But basically, to solve this, again, we can easily override the findAll method exactly as we did before. We can specify that this should join, just like we could do with JPA on planet. So I'm going to fetch all the planets at the same time as I fetch the the records. The other option would be to make the planet nullable, right? So I could have that null association. And now the test is passing. It's doing a select, it's doing a join to get the person and the planet. And it's deserializing, but converting them into records. And it's significantly faster and lighter weight. There's no session, there's no entity manager, there's no state, and it's a much simpler model. Now, the other thing I really like about Micronaut Data JDBC is in the JPA world, it currently it almost encourages you to have a single entity mapped to a single table, right? So, and that's not always the case. So if you look at, for example, this record here, it's got a lot of data that it's fetching. It's got like the name, the height, the hair color, the skin color, the eye color, the birth year. It's got a lot of data, and it seems really wasteful, like to retrieve all of that data, like on every query. Now, Micronaut Data actually does provide a way to retrieve an optimized set of data. So for example, I can actually perform joins on queries, and for example, I can do things like list string, find name, and it knows that sorry, I'm in the wrong person here. List string, find name. So it knows that the person entity, the person record has a name component. So find name by planet name string name. So this is interesting. This is a really interesting query example of a query you can do in Micronaut Data. I'm saying, I want to find all the names of all the people who live on a particular planet name, and you can see that that planet is an entity, is an association, and I'm querying across that association to look at the name of the planet, right? So this is pretty powerful that you can do these kinds of queries really easily, where it's essentially like a join, where I can say just retrieve the names for all the people that live on. I need to look at my data set here. I don't have all the Star Wars planets in my head, unfortunately. I'm really sorry. But you can basically say, find me all the people that, the names of all the people that live in Alderaan, and we can print those out, and let's see if that works. Okay, so that worked perfectly. So basically, if we look at the results, you can see that Luke Skywalker, C-3PO, Darth Vader, Big Anakin Skywalker, they all live on this, or supposedly live on this planet called, or they are from this planet called Alderaan. I don't know if that's factually accurate. I have no idea about Star Wars, but you can see I'm doing a query that says find an optimized query that's just retrieving the name of the people. It's not retrieving the entire person record, and that's a lot of optimizing queries is about retrieving just the data that you need, right? Just not the whole data. But the other thing you can do with Micronaut Data JDBC, which is really cool, is encourage the fact that you shouldn't need all the data. So I can define another record here, which is just maybe name and integer height that maps to the same people table. I can have as many records as I want, right? And I can use that in my person repository, and I can say find all the simple people. Simple person, and Micronaut Data will, or probably I need a whole different, because of the join it's failing to compile. You can just call it list or something else. But basically, with this arrangement, Micronaut Data will produce an optimized query to just select the name and the height, and not all the data, right? So it's like a data transfer object, because I see it a lot in JPA applications where people just retrieve the whole entity, every request, right? The whole chunk, just send the whole data over the packet, and then send it over HTTP as well. Retrieving just the data you need is like super important. It's really, really important. Another thing that is important as well is optimized writes. Micronaut Data will help you write the right amount of data. For example, you can define queries like save, where I say save, where I can write queries like this, and it will help me, and it will infer from the parameter names what properties we want to use for my writes. It'll allow you to do optimized updates, and you can do update by. So you can do a query where you say, I want to update by last name is whatever, there's a lot of flexibility here. Now, everything I've shown you so far has been basically the Micronaut Data, the blocking versions, JPA and JDBC, but there is also another implementation of Micronaut Data called R2DBC. So if you want to go fully reactive, right? And again, I'm going to come back to my application here, and I'm going to drop into terminal, and I'm going to do a git reset head hard to go back to my current state, and I'm going to check out R2DBC. And again, all this has done is reconfigured my application's dependencies to use Micronaut Data R2DBC. And the difference here is I'm fully reactive programming, right? So I can say class person repository, and I'm going to, interface person repository, and I'm going to go going really quick here because I'm running drastically out of time. And I can say I'm going to extend reactor CRUD repository, and it's going to be of type long, and this is going to be an R2DBC repository with a dialect of H2, and I can inject this person repository into my application, and now instead of blocking types coming back, what I get is a flux, right? And obviously I can call, and this is not what you would do. I can call, I think it's called collect all, and then block to, return a list. Of people, and basically, list, and basically iterate over that list of people, and basically do the same thing. But basically, with Micronaut Data R2DBC, we have the same programming model, everything the same as Micronaut. What have I done here? Can't decode. Cannot decode or type long. I don't know what I've done there. Okay, well, anyway, I'm running out of time. So basically, with Micronaut Data R2DBC, we have the same programming model, except with Reactive. So you can see in here, instead of returning a Reactor CRUD repository, instead of extending CRUD repository, we extend Reactor CRUD repository. And we have implementations that use mono and flux and so forth. And what it means is you can write a fully non-blocking application. Micronaut is based on NetT, so that you can communicate with the database and write an end-to-end non-blocking application, right? Instead of offloading all of the interactions with the database to another thread pool, you can run everything on the event loop and build really efficient applications that don't block. It does mean that you have to essentially change your programming model and get used to reactive programming. But there are significant advantages to being able to not block. So in terms of JDBC versus R2DBC, obviously, as I said, JDBC is blocking, synchronous programming model. JDBC itself has a little bit of an older, more dated API, I guess you could say, but it's very mature, and it's very well integrated into the entire ecosystem. R2DBC provides that non-blocking reactive programming model. It's got a more modern API, but the driver ecosystem is still evolving, and of course, it's less integrated into all of the ecosystem. But it's coming along, and it's getting there, and Micronaut Data RDBC is really awesome. So I actually don't know if I'm going to have time to demo. I think I was overly optimistic on the amount of demos that I have prepared for you today. I was going to demo as well Micronaut Data MongoDB. So this is the most recent edition. And the only real difference, again, you can use the same programming model, the same repository system, the same everything. The only real difference is you'll notice in the ID type here, for the records that I'm defining, that the IDs are object IDs, right? So Micronaut Data uses BSON underneath the covers. And what's really interesting about Micronaut Data RTDBC is it's built on top of a new project called Micronaut Serialization. So what we did was we built Micronaut Serialization, which is a new serialization and deserialization framework, which allows you to serialize and deserialize JSON, for example, in a completely reflection-free manner. So in newer versions of Micronaut, you don't even need to use Jackson. You can implement complete applications that are completely reflection-free without Jackson, serializing, deserializing JSON. But we're using the same implementation to serialize and to encode and decode BSON. So that means when you interact with MongoDB and you read and write objects from MongoDB, you're doing so in a completely reflection-free manner with Micronaut Data MongoDB, which means has a number of implications. It's hugely performant, it's super fast, and it's automatically GraalVM native image compatible. Right? So you don't have to configure anything, you don't have to need to think about configuring anything. It just works with GraalVM native image. So yeah, I don't have time to demo it, but Micronaut Data MongoDB is the latest edition. And like I said, the only real difference is that you define a repository, let's call it a person repository, that extends from CRUD repository. And you have your person, and instead of long IDs, we have object IDs. Let's see. And the only major difference is we specify that this is a Mongo repository. And we annotate it with Mongo repository, and encoding and decoding from the Mongo driver is done automatically using Micronaut serialization via BSON encoding. And it's super fast and reflection-free. We also support both the reactive MongoDB driver and both the reactive MongoDB driver and the synchronous MongoDB driver. So that's pretty awesome. And the other thing is that we support custom aggregations and advanced use cases. And we also support, I don't know why this display thing keeps happening to me today. It's not my day. So, you may be interested to know that as well that Oracle Database, in the newest versions of Oracle Database, actually supports the MongoDB drivers. So who actually knew that the Oracle Database supports the MongoDB client drivers? So you can actually use Micronaut Data MongoDB directly against Oracle Database to do document JSON interchanges. And of course, it's fully native image compatible. So to find out more about Micronaut Data, you can go to the user guide documentation. We also have great guides that include sample code where you can try out Micronaut data. These guides are awesome because they include sample code you can download and try. And we have guides for Micronaut Data JPA, JDBC, and MongoDB. There's also, I didn't have space to link it, but there's also a MongoDB Reactive a guide as well. And soon we'll have an R2DBC guide. It's in draft. It's going to come out soon. And you can create an application with Micronaut Launch. Just look for the data features, and you can get started and build applications and enjoy using Micronaut data. What's coming next? So we're investing a lot in Micronaut data. And in a few weeks' time, we're going to be releasing Micronaut 3.6. And I'm really excited because there's some good improvements coming in. The big improvement coming is we're releasing Micronaut Data Hibernate Reactive. So Hibernate Reactive is a new project from the Hibernate project, which lets you use kind of JPA Hibernate model, but on Reactive. So we're launching Micronaut Data Hibernate Reactive in a few weeks' time. And that's going to be awesome. Later this year, we're launching Micronaut data for cloud document databases and extending it. And then next year, we'll be looking at graph databases and other things like multi-tenancy. So I think I'm out of time, but summary, Micronaut data is a comprehensive toolkit for accessing a variety of databases. It's awesome, and it works great with GraalVM native image. I don't know if I have time for questions. I'll take questions afterwards, but thank you very much for attending my talk, and apologies for the issues with the slides. I don't know what happened there. Thanks very much for attending my talk. Do come and ask me for questions if you have questions afterwards.